Hello, Sam.
Hi, Sam. This is practice problem number 6. Please do extra practice problem number 6 as well.
Isn't the one that you said was really hard?
Yes. Okay, so our charges here, we've got a positive 2.4 microcoulomb, we've got a positive 1.2 microcoulomb, we've got a distance of 0.40 meters, we've got a distance of 0.20 meters, and a charge negative 1.2 microcoulombs. Okay, so now we need to think about these angles. How in physics do we always measure an angle?
From the positive x-axis.
We always measure the angle from the positive x-axis. So what would the measurement of this angle that they've called 75 degrees be? See, that's nifty.
175? No.
Well, 180 plus 175 would be what? From the positive x-axis all the way around would be
255.
Very good.
Alright, so we've got an angle of 255 there. How about this angle they've called 19 degrees? How much would it actually be?
360 minus
Yeah,
19.
that's
Okay, so what's 360 minus 19?
341. I was gonna say. Sure it works.
No math, I know subtraction. Multiplication? No.
Okay, so forget about 75 and forget about 19 because they are not the angles we want to use. Now I'm going to digress for a minute and I'm going to do another drawing that will clue us into something fascinating. Okay, so let's say it's very similar. But instead of having a negative charge here and positive charges here, let's say we've got a positive charge here and a negative charge here. How would this, let's say this was still at 75 degrees, this is still at 19 degrees. How would changing this from a positive charge to the negative charge change the way you measure the angles? Because this is a key to one of those test
Would
questions.
you go the backwards?
Well, which way is this negative charge going to push this negative particle? So we're going to extrapolate our line here because the direction of the force is this way because they're repelling. See, this is being attracted that direction and attracted that direction. But this is being attracted that direction, so we still have that 255 degrees. But it's being repelled that direction, so it's going to travel along that line. So what would my, if we know that we have this law here that says that my opposing angles are equal, then what is this measurement going to be?
161.
Probably 161 degrees. 180 minus 19. So.
Wait, so I'm kind of confused.
Yes,
Why would
me
you
too.
change the angle?
Okay, because this is a negative charge and this is a negative charge, and they're going to repel each other.
So
Don't
if
you
we-
just take it
if
off?
that
This
So
was-
the
is like-
force is going that way.
So if we, like for the first one you did, if that was positive as well? you'd
Yes,
be-
if this were positive, they'd be repelling each other.
Okay.
Since it's negative, they're attracting each other. So you have to think before when you're drawing these and picking out your angles, what's happening here? Are they being attracted? Well, then it's going to travel along this line and measure the angle to that line. Are they being repelled? Well, it's going to travel along that line. You measure your angle to that line. And extra practice problem 6 should give you a little bit of an opportunity to use that. But in this case, we're not doing this in regular practice problem 6. They're two attractive forces. So we're going with this drawing. Now, all the fun we can have here. We have to find both of the forces first, right? So, what is the force I should like keep two separate colors. So, let's see. I'm gonna make the force orange between that guy and that guy, and maybe my green works today. And green between that guy and that guy, and I'll try to write the correct colors here. So, what is my force between green guy and the middle charge here? So, all right. So, did anyone find an answer for that? What do I have here? Newton.
This is practice problem 6.
Yes.
6.5 times 10 to the 5th newtons.
Tell me if you see a mistake here. 6.5 times 10 to the 5th. That's what
Anybody
you got
else
for
have
that
that?
force. And it's what I got too. Good. All right. Anyone else find the orange guy's force?
Yes, I got, oh, not for the orange.
The force between this one and that one? Oh no, I did that wrong. It's this. Green, oh wait, no, green guy's 2. That's right. That's right, that's right. That's 4. Alright. So what is this gonna come out to for force?
8.1 times 10 to the 4th newtons.
Alright. And that's what I got too. Okay, so we have our 2 forces. Now it asks, what is the instantaneous electrostatic force on the green, well, not the green, I guess, this negative 1.2 microcoulomb object. So how do we find the instantaneous force if we have 2 non-equal and opposite forces pulling on it? Well, we have to do that monster like cosine sine business, right? So where am I going to fit that exactly? I think I'm going to move these numbers up in the race. So this 6.5 times 10 to the 5th newton, and this 8.1 times 10 to the 4th newton, and then I can erase that next space because this board isn't big enough for the 2 of us. Okay. So, how do you guys like to set these up? Do you remember your methods? Whatever works for you. And then I just plug in 1. That's a 5. 8.1 times 10 to the 4th newton. 8.1 times 10 to the 4th newton. And x is always cosine, y is always sine. And then you plug in your angle, which for this guy is 255. And for this guy, 341. And what do we get?
A whole bunch of numbers.
Does anyone actually have this problem done? Should I just sit down and wait?
I've done it here.
I was very confused.
You guys were good at this. You're the best class I've ever had at these problems.
Do you want all the numbers for all those?
Oh, I actually like these problems.
And
You don't like
Michigan
these
skeleton.
problems?
I don't believe it.
So
Yeah, I do.
the x dimension of the 255 degree is negative 1.7 times 10 to the 5th newtons. The y dimension is negative 6.2 times 10 to the 5th newtons. For 341 degrees, the x dimension is 7.7 times 10 to the 4th newtons. And the y dimension is negative 2.6 times 10 to the 4th newtons. Then we add the x's and y's together, right?
Okay, so x is going to be negative 1.7 times 10 to the 5th newtons plus 7.7 times 10 to the 4th newtons, which gives us what?
Negative 9.3 times 10 to the 4th newtons.
Let's look at that all broken down. So 7, 1, 2, 3, 4 minus 1, 2, all that goes out here. Hold on. 1.5. 1, 2, 3, 4, 5. 1, 2, 5. And then 7, 1, 2, 3, 4. So where do I have significance? I have significance right here, right?
But you're subtracting the bigger one, so
Yeah.
and that's 7.7
So
times 10 to the 4th. So you want another 7 there.
7.7. This.
Yeah.
Beautiful. Okay. Okay. So 0, 0, 0, 3, 9, right? So if I can only be significant to here, what's my answer really?
Oh, 9 times 10 to the 4th newtons.
1, 2, 3, 4. Okay. Now, and that'd be a negative truly, right?
Yes.
Because the negative number is the bigger number.
And then the y dimension is
Yep. That's great. Good.
6. No, I guess it would be 7. One significant digit. Negative 7 times 10 to the 5th newtons.
10 times 10 to the 5th plus negative 2.6 times 10 to the 4 newtons and newtons. And we've got 6, 1, 2, 3, 4, 5. 2, 1, 2, 3, 4 equals 6. Significant here, so 6.5.
Oh, okay. So, yes. Negative 6.5 times 10 to the 5th newtons. Don't think about it too hard, you might confuse yourself.
Today is a great day to confuse myself. And everyone along with me.
And it's a negative.
6 times, yep, if they're both negative, so obviously.
And
How
then
about
we take
6.6? You. 6.3 times 10 to the 5th. Oh, I got 6.3 here.
okay. 6.5 times 10 to the 5th times sine of
Hold on,
255
let me
degrees.
see a calculator.
Here, you can use this.
Oh, no, I can't.
You can have
But
this
thank
back.
you. Oh, thanks. Just real quick.
Oh yeah, it is,
times
because
sine.
it's 6.27, so 6.3.
Okay. Pass it to Stephanie, please. Alright, so we're going with 6.3 here, 6.3 here, so we get 6.6 here, and we're good now. Alright, so how do I find the magnitude of the sum of these two guys?
You take the square root of the x squared plus the y squared, if I remember correctly.
Alright, When I do that, I get 6.7 times 10 to the 5th newtons. And how do I find
Yes.
the angle? Is that inverse tangent? Y over x. Do I remember anything?
And that gives you 7.1 when you get the degree for that. That's your tangent. When you get the degree, it's 82 degrees. And then you add 180 because it's in the third quadrant. So that
Yes.
gives you 262 degrees.
We, I think, can only go to one significant figure
Oh,
here
really?
because we're dividing by 1.
Oh,
So we
yeah.
gotta go to 80. Plus 180 is 260 degrees. So I gotta think about that. When you're doing the square root, you're adding and subtracting. I think you can treat this like adding and subtracting. So it'd be 1, 2, 3, 4, 5. 1, 2, 3, 4. More significantly here. So yeah. Why can I not add? Oh, I'm subtracting. That's why. I'm subtracting this. 6 minus 9. Public math. Alright.
Wouldn't it be 57? Because you take 1 from there.
57. So this right here. Oh, but it's square root then. Well, you can't even do that because it's squared. But the premise is the same.
Whoops.
That you're adding and
Sam didn't see the
subtracting.
last bit. Here, Sam, look at that.
I will not bust you on significant figures on this because this is so unclear. Are you adding, subtracting, multiplying? Who could say? You're doing all of
I
it.
think when we did that, we figured out it was adding.
You
Yeah, 'cause
kind
you-
of do it like
you
adding.
multiply
Yeah.
first, then you add.
And then is the
I'll be
square rooting
nice.
dividing or what? Maybe they have a
Right.
whole other rule for that.
Right. There are rules for that, I'm sure,
Did we
but
make up a rule for square rooting?
he has something in the book about that, but I don't actually remember. And I'm gonna be fairly nice. If you guys are doing a good job of producing a decent answer, I'm not gonna nitpick the significant figures, but
Mrs. Matthias, I'm getting 80 or 82 degrees instead of 80.
okay, but it's a significant figure thing, because you have 1 here when you are dividing.
Okay.
You can only get a 1. It should be 82, but it rounds. So, how much time do we have left?
I don't remember what time we get out.
25 minutes.
Okay, let's build some after skips. So finish writing whatever you're writing. We'll do 3 groups, and I'll build a 4th one for me. And then we'll charge. You're gonna write a big lab report on this, so get ready to call.
Goody.
Pair up in groups of 2.
No.
Splendid river.
If you
Should we
bring-
turn this off for now?
Yeah, turn that off and I'll film it once.
Goodbye,
we do
Sam.
something.
We're